Hello and welcome back to our next stage in our creating a game in the Unreal Engine. And yeah, let's have a look at this. I'm just going to close this window because it's a little bit noisy outside. Isolate some of that road noise. Okay, if you remember rightly, we had all this alphabetic spaghetti going on for connecting the cables on a construct script on the cable itself, which is just no good at all. So what I've decided to do is go ahead and create a tool. So this tool is going to allow us to attach cables. Now the thing is, I've done a hell of a lot of work in the background here, so I'm going to try and keep up and explain everything I've done so that you can see and follow yourself. If there's anything I've missed, something I didn't explain, please point it out, and I'll do my best to do sort of like a recap video, maybe just going over those points that maybe got raised. If it's just general asking about how do I do this in Unreal, I won't be answering those, unfortunately. But anything to do with what I've created, and if I've skipped a step or not showed you something, that's different. I will go through that, but you really do need to have a little bit of a grasp on the Unreal Engine. Okay, so what I will do first is I will show you our new tool base. So I'm going to drag this in over here and put that up there. Okay, so this is basically a tool, and what I've done is I've created a, if I go on here, click add blueprint class, and it is an actor component just like we did before, and I've named it, this one, BPC underscore tool underscore base. That's because it's a blueprint component. It's going to be taught for all the tools, the base for all the tools, hopefully all of them, and obviously base, just so we know that's the base. So from this, I can create all of my classes. And if you see here, I've actually, no, I haven't put it in there. I've actually got it in. Let's have a look. There we go. A new folder called tools. So at the moment, I have, is that the old power tool or the new tool? Oh, I'm getting confusing myself. Cabling tool. What's this in here? Let me just double check. I think I've got an old one. Yeah, that was my original old one. It was a little bit messy that I started playing with first. Don't think I'll be using that. So that one I'm going to move and mark as deprecated, or just delete it because I don't actually need it. But anyway, so I created this blueprint component. So all I did, I created a slot for an icon. This is for later on when we start adding icons and we have a toolbar, that sort of thing. And it's just a variable and it's a canvas icon. That's all it is. That may change just to image or something, I'm not sure. I'll just put that as a placeholder for now. I created a name with a type of name, a tooltip with a text box, a text input there, and also a reference to a widget. Now you can't create this at the moment. We'll create that later on because we haven't created the widget yet. The widget is going to be for your HUD. We'll go over that before we go into too much detail over stuff. I just want to show this base class. So also in here we have an activated, so whether the tool is on or off. In other words, is the tool in use? So if you've got a hammer in your hand, you activate the hammer. If you've got a saw in your hand, you activate the saw and deactivate the hammer, yeah, and so forth. The trace distance is the distance from the player that the tool will work. I've got this set to 1,000 at the moment. That you can change to whatever you need, and you can change it when you subclass and make your child's. So sorry, there is glass cutting going outside with some heavy equipment, so I hope it doesn't show up on the mic too much. So yeah, that's our distance. We call it tracing, so that's the distance the tool will reach. I might rename that to tool reach at some point. But yeah, that's that. These are debugs. Now, I've got these in here on purpose because this helped me debug what I was doing, because I didn't have a HUD. And because I didn't have a HUD, I had no point of reference for the center. So I wanted to see if my traces were firing. And I wanted to see where they were landing and what they were giving and so forth. So I could turn them on and off by using this boolean, debug trace. That's how long each trace lasts, so set it to 3 seconds. Probably one's probably better off for now. That was a bit too much. And the type of trace you draw, so 1 frame or for a duration or completely persistent. I'd say don't use this persistent because you have to flush all those draw calls afterwards. It's a pain in the backside. So duration or 1 frame, just so you can see what's going on if you wish to use the debug. And if you have any issues, I would say put these in, and I'll show you why, because it just makes life so much easier. So yeah, the only thing you can't do, all you could do there is put HUD widget and give it a type of widget, user widget or something like that. And I've made all these visible. I don't think I put them all on spawn. Activated wouldn't be on spawn. These will be exposed on spawn actually. I would guess. So then if we need to create new ones, no, we don't need that one. Yes, we do need that one. Sorry, yeah. We do need to change them on spawn. We can. So this is the base class, and as you can see, all there is variables. So that type there is eDraw debug. It's the actual debug trace. When you do a trace, that's the debug visibility type. So it's eDraw debug trace type. It's just so you can set, if I click on that, the different types. That's all. So what have we got in here? Well, we don't have a lot. There's nothing in the event tick because this one isn't going to be used, so I'm going to delete that, and I'm going to begin play because we don't need those at the moment, not anyway. So all I've got is 3 custom events. Now to create a custom event, you right click, type custom, add new custom event, and give it a name. Just type the name in. Yeah. So I'm going to leave these on the screen for a moment. You might want to pause it if you want to see what these are. And all they are doing is turning the tool on and off. And so, sorry, activating the tool as in activate means it's in your hands. Deactivate means it's not in your hands. Okay, that's all it's doing. So once activated, it means it's in use, it's ready to be used. So all I'm doing is on activate, I activate this tick. That's all I do, activate this tick, just to say yes, this is the one in use. And when I deactivate, it unticks, so it just changes this variable, nothing else, nothing more. On, off, activate, deactivate, simple. Just compile that and save that out of the way. Then I've also created 2 actions. Now what these are for is for passing through your clicks. So it's either going to be a mouse click or you may use a controller. However which way you want to do it, you need to pass that through. So this is what we will fire on the active tool, because on our player we'll have an active tool. And the active tool will be referencing the one you actually got in use. So if you select number 1 on your hotbar and it's this tool, this one will be activated and this will receive all the events. Nothing else will, just this one. Okay. We may look at passive tools later on, like radar, that sort of thing. Yeah, but that's by the by. For now, all we need is these events. That's all that's in here, nothing else. And that is our base. That is our tool base. Okay, so what I did, I stored that in a tools section and I put it here as the base. Okay, that will probably stay there. The cabling tool I've got will go in there. I'm not going to move it yet because I've still got the old one there. I've also created this as well, but later on we'll go through it. It's an interface. It's just a way of detecting things. So what did we do from there? That now enables us to create a child. So you right click, create child blueprint, and I called this one cabling. So this is the tool for cabling. So this is a child of this. So we'll open this. I think it's already open in my other window, so let's drag it in. And here we are. We have another tool. Now, to be honest, there's not a lot in here either. Not a lot at all, which I'll go through. It looks a little bit wibbly wobbly, but I haven't had time to sort of jazz this up a bit. So this is a child, and it's basically, it has all the events that the parent did, the base. It has all the variables, even though all the variables aren't actually showing here. There is a way to do that, and it's class defaults. So if we click class defaults, all those variables that we had here, all those are in class defaults here. So I've given this one now a name. It's called the cable tool. Tooltip, it allows the connection disconnection. The widget we don't know about in the moment, and I've not put in an icon. Okay, my trace distance is set to 1,000 still. I can change this if I wanted to, but I'm happy with that at the moment. Activated I won't change because it's not going on or off. Our draw traces are on there. Now I've actually got those activated at some point because we have a very large function here, and you'll probably get scared when you look at it, but don't worry, it's not as nasty as it looks. So yeah, these are set by default to nothing, but I do switch them on and off in here within this function, just so I can test a few things. But yeah, so all I've done is edited the variables in here that I need to, like the name and the tooltip. Nothing else needed changing, to be honest. I've left all the defaults in there. So that's how you get to the default configs and variables. If you can't find one of your events which you want to override, because obviously we do here, and I'll show you more about this in a moment. You come to functions, override, activate tool is one. So what I did to get deactivate tool, I clicked on that and it puts it there. Yeah, I'm not actually using activate tool at the moment because I don't need to do anything other than switch it on and off. The reason this is here on deactivate, I'll show you that shortly as well. Okay, and we're using event tick. Now we have to use event tick because it's going to be doing a trace. Okay, so what we're doing, event tick, we'll call its parents tick, but there's nothing on the parent tick, but I'm leaving that in there just in case I ever modify the tool. So that will call whatever is on the event tick that's here. Obviously there's nothing because we deleted it. So that will happen first, then it'll call whatever's here. So on event tick, what do? Well, we're checking what's going to happen on this, because it's a cabling tool. This is, once it's activated, you're going to have to want to check where you can connect a cable to, and you do that by visibly looking. So there's going to be always a line trace running. So to get that line trace running, there's no point doing it if this isn't the active tool. So on the event tick, we're checking if this one is activated. Okay, if this is the one that's activated, we go on and do our which is called find target. My alphabet is spaghetti here as well. Don't worry, this is actually quite basic once you get a grip on it. I'll explain it actually while I'm here. Find target is my function here, which I will scare you with in a moment. When it comes out, it then does a branch, and this function returns whether it's found a valid target. Okay, so what the valid target is looking for is an actor that has power connections, and it will return the actor, the actual connector we can connect to, and the port for lining up to. Yeah, I've changed them slightly on the generator as well, so I'll go through those afterwards. I'll explain to you what those are. And at the moment we can't really test anything because this part isn't actually fully finished. I've got the checks working, but now I've got to program a way to connect the cable, but that's easy enough. So what happens, it checks to see if this is a valid return. So if I'm pointing, that's what this does. This find target is a function that fires traces into the center of the screen, and it returns a value based on information that it needs to sift through some filters and things, just to say, right, is this a powered object? Yes. Okay. Is this a port? Yes. Okay. Is this got a connection? Yes or no. If it has, then you can't connect to it. If it doesn't, yes, it's valid. After that, it says, right, okay, this is valid, and it sends all the information we need back through. So all this does here is if that object is valid, and the port is valid, and the connector is valid, and we're allowed to connect to it, it will come out here and it will set the target actor here, and then it will set the target connector here, which is our BP electrical connector base. Yeah. So now we know that this has a connector base, so we can get access to it. We know what the actor is in case we need access to that, and also the port. I've set that as a scene component. Can't read it there. Let me just. There we go. Scene component. Okay. They can pretty much pick up anything, but that is what we're using as the port. That's what we're detecting, and how we detect that, I'll show you that shortly. So we're just setting these variables. That's all we're doing there. It looks a bit messy, but it's just kept it nice and simple and compact. This here, this set, it's accessing a widget, and it's showing an icon whether the port is valid or not. That's all. It's just so your visual thing to say this port is valid. And this one is just the opposite. If there isn't a valid return, it unsets all those. As you see, there's no inputs on them, so it unsets them, so they'll all be empty. And we hide the icon. Now let me just show you the icon. If I hit play and ignore my little dot in the middle, I'll show you how that happens as well in a minute. Well, not in a minute, but at some point. So as you can see, nothing's happening. Yeah, I've got my little dot. That's my center of my screen. That's what I'm using to aid me. At first I used a trace. Now what I've done is I've left the line traces visible. So what I'm going to do is I've assigned key number 1 to the cable connector. So I hit 1, and you see that red dot? That is actually line traces. Look, I've set them to only 1 second, so it's constantly firing line traces and hitting things. Yeah, and it's going only 1,000. See how it's not hitting anything there, but it is there. Yep. Okay, now watch this as I go over a port. It's a valid port, and that means that the port is as intended. It's a proper connector, and it's not connected to anything. It checks to see if it has a connection. So now we've got all this line tracing, and we go from one to each. Now what I'm going to do, if I hold shift and F1, if I come down to my player character and I come down to my tool, target port, target connector, target access actor. Yeah, so I can set all those from looking at one. So if I move around and then point at that one, it highlights, and it's choosing at the moment ECP output C1 and the connector that matches it. Yeah, and it's also telling me what the actor is that I'm pointing at. Come off it, nothing. Next one, C2, C3, C4, and the connector that's just above it, shift F1, this connector here that's just above it is the same connector. If I stretch it, see, I don't know why C3 and C4 have got different, that's interesting. I've never noticed that. Are they all C1? Oh yeah, it starts at, yeah, because they're dynamically created, it looks like it's wrong, but it's not. It's matching. It's just it's a 0 base where I did a 1 base. I might actually rename those to 0 to 3 just to make it a little easier to understand. So as you can see, we're firing a line trace at these objects, and only objects that are valid to connect to are highlighting. Pretty snazzy, eh? Yeah, it took me a while to do. I had a lot of messing about. So let's come out and let's go back to our cabling. We don't need the tool base anymore for the moment. So I hope that's simple and easy enough for you to understand this. All it's doing is setting the variables and setting the visibility of that little lightning bolt that comes up above And that's just a HUD class. You could ignore that thing for now, leave that completely disconnected and not do anything about it. Before we go on to this, I'll just show you a couple of things that I've added in. Ignore the action start because that's not finished. It's just, I was about to start. I thought, oh, let's get this recording done. So the only thing I did was I put this on. Now, what happens if I disconnect, if I turn off the tool, sorry, whilst in the middle of pointing at something? Let me disconnect this and we will show you what happens. So I'm going to now run this and number one, turn the tool on. Oh, number one, turn the tool on. And see how the lightning bolt comes up and then it goes away and it comes up. But if I turn the tool off, which I have. Oh, no, I haven't. Oh, it looks like the deactivate isn't working because I've deactivated all of it, so I can't. I had a little bit of a problem with this earlier. I should have disconnected there. Basically, I forgot to. That part deactivates the tool. It's in the parent, so let's go back. I had a few problems earlier on, so I was messing about with a few things. So let's turn the tool on. So as we go on and then off, yeah. So if we're aiming at it and then we turn the tool off and move away, I'm not running the tool, but the icon's still there. So all this is doing here is turning the icon back off when the tool deactivates. It doesn't need to check whether it's visible or not. We'll just turn it off anyway. What's the use in having extra code to check when you can just turn it off anyway? Okay, so I hope that's straightforward enough. This now is our important bit. You can either double click here or double click here and you will see my nice bit of code. Now it's actually, it looks like a lot, but it's not as bad as you think. I've created a sequence here. The reason I've done that is because it just keeps it tidier and more condensed. Otherwise I'm going on and on and on, and you just, yeah, there's just only so much real estate when you want to see things. So let's go through stage by stage. So this is called find target. That's all it does, and it has some outputs, and these are the outputs we just looked at. A boolean called valid with a question mark. You don't have to put the question mark. Or call any of these anything you like, just remember what they are, that's all. To say return whenever we've got a valid object. If we haven't, it'll be false. If we do, it'll be true. The port will be a scene object, which is what we connect up to, which is the physical port as such, to make it look like it's in the right place. The connector is the invisible component that handles the power input and output. You don't actually see that, but it's connected to it's connected via one of these, and we'll show you how in a moment. And the actor. So basically this will be the generator. Yeah. But obviously that will be different when we use a light. So that could be anything at all that's powered. But at the moment, it's a generator. So to add these in these outputs, you just click the little plus here. Make sure it's not on the inputs. We don't need to explicitly pass any inputs because it's got access to everything it needs. It's directly in the component there. There's nothing we need to pass because we're not in the middle of like a loop or anything. So yeah, you just hit the plus here and set each one of these to actor. That's a BP electrical base connector, scene component for the port, and a boolean for the is valid. Okay, so let's start at the sequence here. 0. Our very first sequence. So let's put this in first. This here basically is a little routine for getting the direction in which the player is looking, and it's done from the camera because obviously the camera is your eyes in a first person. Doing this in third person might be a bit more awkward, but unfortunately you're on your own with that one for now because that just is out the scope of this tutorial, but it can be done and you can make a workaround for it. But this is for first person. Let's zoom in a little. I think you use, is it shift or control? Control. You can zoom in even more. Okay. So yeah, if you hold the control key, you can zoom in past the 0. See? So we get the player camera manager. This stores the camera information. We can't just access the camera directly. So we get the camera manager because we don't know what camera is actually active, do we? And rather than explicitly declaring it every time and storing another variable, which we don't really want to do, there's no need. So we get the manager, and from there we get two nodes of it. I would like to have just got transform and use that to split to what I want, but there is no transform. So we need the location of the camera, and that's where we're going to draw our trace from, where we're stood. So from the camera, and then we also need the camera's rotation. Now the reason we need the camera's rotation, because from that there is a node that automatically derives for the forward vector using the rotation. So that basically lets us know which way we're looking using a vector. Okay, and so it'll just give a number between 0 and 1 in each of the 3 vector directions, X, Y, and Z. I just did that American style, didn't I? Z, Z, yeah. It uses that, and it returns that vector, a number between 0 and 1 in each one of those aspects, so we know which way the camera is looking. Okay, so camera location, why is that important? Well, let's zoom out. Well, we'll go into that in a second. There's a little bit of code here at the top which I'll go through afterwards. This is about the debug I was talking about earlier, but we'll ignore that for now, and we'll just move on to the line trace. So we need the start position. So the start position comes all the way across and goes into the start position on the line trace. So it's a normal line trace. Okay. Ignore these two. We'll go over those in a sec. And then we need an endpoint. Now, to find our endpoint, we need to get our forward vector. Yeah. Times it by the distance. Remember this trace distance, which we set to 1,000? So we times it by that. So that means we're going to be looking 1,000 units in this vector ahead. But that's local. That is just a local variable. We then need to add this, because this is now just an offset from where you're stood. So we add this to the player's location. So we get the player's location and we add the value of this multiplier to it, and then we apply that into the end. I hope that's easy for you to understand. So player location is where it starts, and then we add the forward vector, which is obviously, like we said, a number. Well, it could be between -1 and 1, sorry, depending which direction you're looking. And then we times that by how far we want to look in that direction, which was 1,000 units. But then we add that to the camera's location, because that obviously gives us. So this will say we was looking in position X1 near the 0, 0. That would become 1,000 0, 0. But that's not world coordinates. That's local to where the forward vector is. So we need to add that then to our camera's location, which is where our player is, because that's basically what we are, a camera with some arms sticking off it at the moment. So we add this sum to that, and that is our end location. That will then draw lines from the camera to 1,000 units in front of the camera. I hope that's straightforward. These are the default settings on here. Ignore selves normally ticked. I don't mess about the trace colors. Now we'll just quickly discuss this. Those extras that we added in. Now obviously you can't see them here, these variables, but they are still a variable. So if I just type in debug trace, if you look at the very bottom here, the variables, they're still there. They're from the base class, so they don't show in the standard variables list. But they are there, okay? Even though they're not showing there, they are there. They're in the base class. You just have to type them into this bit here. Variables, debug, because that's what class setting will put them in. Debug draw trace, yeah? And get debug trace. These are these, yeah? Okay? So debug trace and debug draw trace. They're the important things that we need to plug into this. Now, all this is doing is, we're doing a branch. Is the debug trace on? Are we switching it on? Yep. If we're not, we'll set the debug trace style to nothing. This is a variable here, and it should be in the local variables. Yep, there we go. Should have explained this a little bit. So we've set a local variable called debug trace style, and it's set to none by default. But that goes into the debug type. So it's set as none by default, as you can see here. Yeah. but we're setting it to none still, just in case we've changed it at any point. So we're not going to draw any traces. Yep. But if this debug trace boolean is true, we're going to set the debug trace style to whichever one we set in our debug draw trace. I've confused myself here. This is another variable that we set up before. Okay. So yeah, sorry, that's from the base class. So whatever's set up in there, it will come across. Okay, so let's go across to the trace. Now, oh, we've also got this. This is one of our core debug trace. If we come down, and one of our duration, set debug trace duration or get debug trace duration. That's another one from the base class, and we're just bringing that through here because obviously it's not in this list here, but it is still there because it comes from the base class, so it is there. That's just the time, how long I want to trace to last on the screen. We set that to 1 second, didn't we? And that's there, look. But you don't need this. You could just come straight in from this sequence 0 all the way across to there, and you can just switch this on by hand if you want. You don't need this. Set it here if you want to. That's your choice. The only thing that's really important here is the camera location and forward vector, the correct math to make those work, to give the start and end points. That's it. Okay. Not everyone knows how this line trace works by channel. We're using by channel visibility. There's no need to change that. You could put a custom one and make one if you wanted, but it's just more messing about. Visibility is fine. Not a lot of people understand how this works now. If you don't explicitly check to see if you've hit something, you're going to get an output log full of errors. Accessed none. Because what happens is, if you just come off here and you don't check this value here, this return value tells you if there's a hit there. See, true if there is a hit, false otherwise. If you don't check that value, but you start trying to access the hit result, then you're going to keep getting errors because there was no hit, so there's no actors on the end of it. I hope you understand that. Now, a lot of people wonder why, I keep getting errors, access none, but it shouldn't do that. No, it won't stop your program. It won't stop it running, but you'll have errors galore in the background, and there's just no point. Do it properly in the first place, no errors, and you won't have to keep clearing an error list every time you run play. So all you do is a branch to check that condition. If it's true, we'll go on and we'll set these couple of variables, which I'll show you about. But let me just show you the false. The false comes out and it just sends back nothing on these because there's nothing to send back because there is no hit. Yeah. And it's going to send back no tick. So that means it's invalid. So when it comes back out, we're just going to say there's nothing to look at. It's going to unset the variables here, these. It's going to make sure they're unset because there's nothing we're not looking at anything. So it'll totally unset them because this is not ticked. Let me just go back to that just to show you how that works. So it comes out, and because it's false, not putting any inputs to any of these variables. Those are my return variables there. Yeah. Sets all them to nothing. And it also hides the electricity widget because there's nothing electricity under the cursor. Okay, let's go back in. So that's what this return node does. Because we've got outputs, we have a return node now. Don't have to use it, but if you want to send the stuff back, that's the best way to do it. And we need to on this because we need to know if we've got a valid hit or not, so that we can set or unset those return variables there. Okay, and that's what actually does this part here. So we'll just show you. It's one stage of doing this part. So if I put this on, turn the tool on, if I aim at that and then shift F1, and we go into our player character and come down here to cabling, that's what sets one part of this. So if it misses, completely misses. There we go. It's not getting any hits. We're not hitting anything. It's all too far away. Yeah, there is nothing in any of those. Even when it's hitting, that comes later on. This is hitting, but it's the wrong type of object. We'll show you how we're doing that in a minute. That's a little bit further down in that function. But when we're not hitting anything, it makes sure it's not. It's actually putting nothing in those objects. Only when we hit what we want will it work. Okay. Hope you're following. So these here temporarily store the action component locally. So basically, if this is true, it means we've got a hit on our trace. We've hit something. Okay, so all we're going to do is get the actor and the component of the actor that we've hit, and we're going to set these to 2 local variables, and that's the hit actor and the hit component. There is one more there, but that's later on. We'll show you that in a minute. So the hit actor, so we set the actor to the hit actor, and all it is type actor, and the current hit component is set to that, and it's just a primitive component. Yep, it doesn't matter what we use there as long as it matches the types. It can be a primitive component or scene component, but as long as it matches a component. Primitive is probably best, to be honest, rather than scene, but I don't think it actually makes too much difference. So that's all we're doing. So we've got a hit. Now what's happening after this? Nothing. It's just falling off the edge. But we're not returning. We're staying in the function. So what happens next is we come back, because there's nothing else there, we go to then 1. So then 1 in the sequence comes down to here. So now we're going to do a few checks. We're going to check if first, is the actor still valid, because it could take a microsecond for us to get here, and in that time we could have moved the mouse. Not likely, but it's possible. We're probably not as quick as the computer, but I'd like to keep myself covered anyway. So we do a get on our actor. Yep. The current hit actor. Yeah, we're doing a get on it. Now, as you notice, this is a different type of get. I don't know if you've ever seen these before. But basically, if you do the actor and get a get, you get this. But you then have to do a valid, is valid, and all that. We can do it all in one go. And the best way to do this is if you right click on the text there, convert to validated get, gives you one of these. So now you've got an input, and what it'll do, it'll get this, but it'll tell you if it's valid or not at the same time. So it just condenses your code a little. Not sure if it's optimal. Well, not sure if it will make it more optimal, but yeah, I think it's just a lot easier because it's now giving me plugs to go places rather than another branch and another check at this and so far and so forth. All right, so if it's not valid, if it has suddenly disappeared, we're going to do another return node with a no valid tick, because there's nothing in these but no valid tick. So we're sending back to say, no, sorry, this is no good anymore, because for some reason the actor's now disappeared. We've moved it that quick, it's no longer there. Now, this bit we haven't covered before, and it's another thing I've got to show you. So what we're doing is we're checking to see if this object implements something called an interface. Now, you may or may not know what an interface is, but for those who don't, I've created an interface. Okay, and let's go into a content drawer, and where did I put my interface? Did I put it in here, or did I put it in the cabling tool? In the cable tool here. That probably won't be in there. It'll probably be in somewhere else, but for now I'll put it in the cable tool, but it will probably move. So let me show you how to make one first, and then I'll show you what it looks like. So to add an interface, and the best way to do this is probably to right click, and then I believe it's a blueprint, yeah, up to the blueprint section, and then down to blueprint interface. Click on that, it'll give you one of these, and it'll let you name it. So you name it. I've called it BPI_power. Blueprint interface power. This is what I'm going to use for anything that has some sort of power, input or output. Okay, so we know what these are. I don't think I'm going to change it for the generator yet, but I might do. I might have a separate one for power user and a power supply. So for now, we've just got this. I'm going to open it. As soon as you open it, it's going to it's opened this really strange. Open that again. Oh, that must be the way it's opening. It will ask you to create a function. All I've done is call one power source. I've not done anything with it. And it's got an input called source. But there's nothing in there. I don't need anything in there. All you need is one function just to make it valid. That's all. Okay, so add a function. I've called it power source. And I've given an input of source. And it's brilliant. But it doesn't do anything. Add that in and just hit save. That's it. Simple as that. Okay. That then has created what's called an interface. Now, what we need to do is add that interface to something. Now, all we're looking at the moment is the generator. So let's open the Geni. We'll go through any of this that's changed shortly. When you come into the generator, if you go into class settings, okay, and then you need to I've already added it in here, so I can't show you, but you go to implemented interfaces. Yep. Oh, there it's showing actually there. And then you click add, and then you look for our BPI underscore power, which I've already done, and it adds it in. We're not doing anything with it. All we're doing is telling it that it has this interface. We could use this as communication later on. It might be a good idea to do so, but all it's doing is telling it that this has now got an interface that can use. It can get in these now. You can actually use the functions in there. The one that I've made is imaginary. If we right click on it, implement event and so forth, but I am not using them at the moment. All I've done is created that so that I can connect it to electronic things so that they know they can talk, and for the cable tool to know that it can talk to cables. That's all it does. It's just so we know it's a powered or is a powered supply. That's all it does. So class settings, add, put the name of the interface, which is BPI power that we used, click on that, and that's all you have to do. Compile and save. Done. And then we can leave the generator again. Okay, so that's what this is doing now. It's grabbing the actor that we're pointing at, and it's saying, does this imply any sort of power input or output? Our power interface. So we put that into the test object, and it comes out with a Boolean. Yeah, so if it does, it's going to fly off the end here, and that means it'll go to the next part in the sequence. Okay, but if it doesn't, we'll ignore it. We don't need to do any more checks. We know it doesn't use power, or it doesn't supply power, because it's not employing an interface. So we're just going to send back another invalid node. See, nothing on there, false. Okay, so it falls off the edge here. It's true. So then it will go to our next one, which is then 2, and then down to this one. Now this one is going to check to see if it has any valid ports. Now this one's quite simple. I don't know if you remember when we did the other, let me just open this up, this Geni again. I'll show you this generator, and there we go. That's that. I'll show you what I've changed here. You'll see, and you'll see why. Okay, we added this in ECP0. That's to tell us it's an output. But I've decided, rather than trying to do some complex, well, not complex, but rather than adding extra code to do some string operations just to see if it's got ECP at the beginning, there's no need for that. So I've just put in a second tag called ECP, and I've done that on each of these ports. They've all got ECP in the tags, and the reason for that is we can now check for that. So does it have a valid connector? So we get the component and we check to see if what we're pointing at is an ECP port, because yeah, the actor here might use power, but you might be pointing to a different part of the actor. There might be another model there or something, and you're not pointing at the port. So this is to detect that we're looking actually at one of those ports. So if we come into our generator and we come in to here, those are our ports. It's no point if we're looking here, the generator's still valid because it's got power. We know that. We've checked that this implements power, but this part doesn't. This does nothing. But these are all ECPs. So we need to know if the thing that we're pointing at is valid for a cable. So it would be an ECP port. Yeah. That's what we named them last time. I can't remember what. Electrical control port. Was it an electrical cable port or something like that? Oh, yeah. Whatever it was. But yeah, we call it ECP, electrical control port. That's what I'm going to say. So what we're doing, we're getting all the tags. And then rather than iterating through them with a for loop, we can just do a quick thing that just says, does it contain this tag? And we let this bit of code here do the work for us. So all I've done is there with no spaces, I've put in ECP because one of the tags we've got is just ECP, capital ECP. I'm not sure if it's case sensitive. I'm sticking to case sensitive just in case. So it's now going to look at this component and say, does it contain this in its tags? If it comes up here, if it's false, again, we can't do nothing with it. So we just return invalid. So at this point we fail again because this is not a correct port. But if it's true, we fall off again. And that then goes to, I think, number 3. Yeah, the last one, I think. Number 3. So we now know that the actor supplies or uses power. The port we're looking at has matched that it's a power port of some sort. Okay. So, what are we going to do? What are we going to do with this? Well, we need to now find out if the port's connected to this. Or is there a port connected to this? Now, there should be, because our code makes them every time, don't we? If you remember in the generator, we create all the ports. I'll show you that again, because I've done that a little bit differently, I think. So I'll go back over it. But what we do, we dynamically get all these and we add ports to them, yeah, and we do the same sort of thing using the ECP. Okay, so let's get that list of ports. So what we do is we get every single actor of type by class from our current hit actor. So sorry, component from our current hit. So our actor is going to be the generator in this case. It's then going to grab the generator and say, right, okay, tell me and give me a list of all the electrical connector bases that you've got on board. So we know there's 4. So what it'll do is it'll output an array of all those objects. So there should be 4, 0 to 3, 0, 1, 2, and 3. That's 4. Yeah, I know it sounds weird. 0 base is always so hard to get used to. So we've got all those. So regardless of how many ports there is, it will return however there are. If there's 1, if there's 10, whatever. This will come out with a full list of them all. Because we don't know what type of object we're looking at, and we decided to do that, and then we'd have to cast to it to then get. So if we were going to get this generator has in the config this already has a list, but we can't get to that unless we cast the object to a connector base. Now we don't want to keep going through casting to different object types because we don't know what they are. This could be a light that we're looking at and looking at just one port on a light. We don't want to worry about casting to different objects. So the easiest way is just get the components that actor has that matches the types we want. So we come along, we're then going to loop through them all. Now, as you can see, it's a loop with a break. The reason there's a break is it's going to get the first match. Now, what is it looking for in here? So we're doing a branch. So array comes in, gets to the first item, and it checks for something. It checks for a condition, a boolean. Okay, so here's an equals. Okay, and what that's doing is comparing 2 objects. So what are we comparing? So if we drag off this element, because it knows, if you see there, BP electrical container based object, because it knows it's coming from there. So it knows what it is. We don't have to cast to it or anything. Yeah, we're dragging off, right? And if you remember in our generator, we had a connector. Sorry, not in our generator. Inside our connectors here. BP. No, which one's which? I think that was the new one I was playing with, which I didn't finish. So yeah, we have in here. Oh, it's not this one. Am I looking at the wrong thing? BP electrical connector. It looks alright. Looks like the right one. That might be the new one though, because I've added a widget in there. I don't know why. Let me just double check before I start talking rubbish. This is, yeah, this looks completely blank, doesn't it? So is this one? Oh, it's into the components, sorry. We have a connection object. The connection object is the physical object to which we're using as a connection reference. So basically, it's so we can get a location where to plug into. So it's where the port is. And it's these domes, which I'll go through and show you those, what I've changed, and why I've changed them. So we have those connectors. They're called a connection object. So in the cable, we drag off here and we type in get connection. Whoa, and there's my spelling again. Get connection object. Okay. Then what we're going to do is compare this current item to our current component to see if it matches. So our current hit component that we set all the way up here, which is what we're currently aiming at, the component, not the actor, the component of the actor that we're aiming at. Yeah, it's gone through all its checks. We know it's a valid port. I'll do it this way. This mouse is slow. I'm using a trackball, so it's meh. So we're getting this list of connections from the object, and we're checking it against this. Now, in hindsight, I could have probably just used a contains, and this would make this a lot easier. I might actually change that, but for now, this works. I will change that another time. So we're checking that the connection object on this current iteration, so we've got 4 different objects in here. It gets to the first one. Is this connection object the same as the one we're pointing at? No. Okay. Don't matter. Bump, comes out, and it goes to the next one. Doesn't do anything else until it gets to the end of the array. That's all a for each loop does. It'll fall off the end. Okay. Until we tell it to do otherwise, which is what the break's for, but I'll show you that in a minute. So if it's not, bump, it falls off, it'll go back to here. If there's still another one to look at, we then do it, it starts again on the next one. Is this connection object the same as the one we've got? Now keep doing that until this matches and goes to true. If it gets to the end and it's not, then it's not going to set a variable that we do later. So let's go for the true first. So it's check the connection object. We'll say object number 2 out of the 4, and we've checked it against this, and they match. Right, we're pointing at this object. Yeah, it's got to be one of them. Has to be one of them because we're pointing at one of them. We know we're pointing at one of them. So we get the matching object. They match. True. Yay! So we then want to check if that same object that we're checking there is connected to something. So we check its value, its value for connected. So again, it just comes off there, and we just type in connected, yeah, and we get the connected there. Okay, and that's all that this is doing. So is that port already connected? Because we might be able to spy the port, but if it's connected, we can't use it. So we just want to ignore it. We don't want it to highlight because we can't use it. So if it's not connected, yeah, it comes out and it goes to break. It stops looking. We found the port. We know we got a match. We found the port, and it's found the connector. We set the connector here. So this is our connector found here. It's just a variable holding the BP electrical container base type. We set it because we found it. That matches. Okay. We set it, but only set it if it's connected. If it's not connected, sorry, if it's false. If it is connected, it falls off and goes to the next one. But then it will most likely fail anyway. So to be honest, this is probably best just to break anyway. So it keeps the loop going anyway. It's fine. But if it's not connected, we set this. If it is, we come out of it at the bottom, which I'll show you. So we set this. We found the connector. It's not connected. Let's send it out. We're going to break. As soon as it gets there, it doesn't matter how many items are left in the array. If we got to the first one and the other three haven't been checked, it doesn't matter. We know they match, and we know that the connector's been found. Yeah, and we've set it here. Yeah, because it's not connected to anything. Okay, if it is connected, it makes a difference. So it's only set if it matches and it's not connected. Yeah, false, not connected. And that's what it is. All this line is coming from is the same here. It's just the array element. It's just a quick way to get it across. So yeah, we're only setting it if it matches the one we're looking at and that port is not connected. Yeah. If it is connected, we'll check that now. This is where we check. Okay, if that's connected, it would have come out true. We won't have set that variable. That'd be blank. It's only a local variable. So it'll disappear once this function's finished doing what it's doing. So because we haven't set that, yeah, because it was true here, then we won't be able to get a valid get here. That's why we've done another one of these validated gets. There'll be nothing there, so it won't be valid. So if it's not valid, it'll come down and you send back and nothing again. Nothing at all. And a Boolean false. It's not valid. Also the same here. If this keeps looking and it doesn't find a connection, this never matches, it will fall off here and it'll keep going around until it's finished, and then it'll come to completed. Break forces it to completion, or completion when it's gone through all of them, regardless of what it's found. Yep. So we've checked now that we've only set this if we've found a valid object that's not connected. So if it's not, send back this. Now, if it's valid, that means we can use this, we can connect to it because there's nothing connected to it. It's a power port. We know it's a power port. We've done all the checks. We then return the actor. We return the electrical connector it found. So that was this temporary connector found here. And we also return the hit component, which is the port. And we use that for lining up the cable later on for where it plugs in. That's the actual communication device, and that's the actor it's on. Okay, so we now have all that, and we say it is valid. Now, if there's a bit of a gap or delay in between any of this, it could cause a bit of a problem. I don't know if I check it. I haven't yet checked it, but I will probably check it when I go to try and add a click, just to double check that it hasn't disappeared or I haven't moved or whatever. So it's now going to return is valid. Yep. That's what this function does. It's basically a check to see if what we're looking at is a valid port and it doesn't have a connection already. If it does, it will send it out, it will return that with a tick, and it will come back to our main tick event, and it will then set all of these. That's all it's doing. Sets all of them. And I enable the picture of the power port. So look, turn it on. Number one, nothing at all. And the power port comes up, nothing. And then nothing, and then yeah, only when I'm highlighting it. So these are all valid ports because there's nothing connected to them. Yeah. And that's correct. It's all perfect. So that's all I've actually really got to at the moment. This is going to be the start of the clicking. And when I click, it will come through to here. I am, as I said, doing a check to make sure, again, that the access is still valid, that nothing's changed. So that's about as far as I've got. I'm hoping I explained that clearly enough. It's quite a mouthful for an hour's worth of chat. I will quickly just go over the generator and just show you what I've done with that. All I've done is replaced. Yeah, let's go to that now. So yeah, I hope you understand this okay. Anything you don't, just please drop a comment and I'll try and get back to you. Maybe do a follow up on it if we need to. So we've now got on here, I'm not sure if I had this electrical connectors thing here before, but what I did, I've swapped all these ports out. Why it puts them in this order I don't know, but they are in the correct order. So all these ports have been added. They've been changed from scene components to collision spheres. And the reason is for easier traceability. I'm not sure if a scene object actually gives a trace result. So I changed these. Now what I also did to all of them, so you can highlight them all. If you hold the control key, you can highlight them all like this. So I set all their sizes and locations and so forth. And then if you scroll down to collision, change the custom collision here. And then what I did is I ticked ignore here on collision response, and all those become ticked. But then on visibility I blocked, because that's the channel, if you remember rightly, what we were doing in our find target, we're using the visibility channel. Yeah, so all I did was tick this one box, visibility block, so that then blocks my traces so that I can pick them up. It just makes it a lot easier to detect. And then also the other thing I did was add in the type of port, which is ECP_0 for an output. Not quite using that yet, are we? But hopefully eventually. But I'm also put ECP in just to say it is an ECP port. Yeah, so that's all I did to those. Just change them for that to make it a lot easier to connect to. I don't think I changed anything else on the generator itself. Oh, create ports. So all I did here, yeah, this was new. So this here, under generator config, I put this one. So it's just a variable, and it's a variable of electrical connector base type. Okay, and set it to an array. Okay, so we can hold multiple items. When this construction script loads, it creates the ports. Okay, that's all it does on the construction script. When it first loads the object, it will create ports. So what it'll do is, just in case there are some in there already, we'll clear them. We'll clear the whole of this array because we don't need them, because we're putting new ones in. We're making sure it's starting with a clean slate and adding new ones. Then we're getting all components in here that have a class of sphere collision, because that's what we're using now, these sphere colliders, and a tag. So it's get components with the S, not without, get components by tag. Sphere colliders with ECP0. So each one of these have got a tag ECP0. Oh, not 0. O for output. ECP0. Okay, so all the colliders with that tag, and it returns them here. Yep. Then we go through them and we create new instances of the electrical connector, because you can see I've not got one in here anymore. Before we used to have that one in here, didn't we? But no, this creates them from scratch, and the target is self, so we're adding these to ourself. So if we just go add component, trying to see where this came from there. Let's just add component to actor, I think. Add child actor component. I don't think it was a child actor. It was, maybe it was. Adds a component to an actor. Okay. Add child actor component. No, it's a child actor. So it's not that one. Trying to think what this node is. Adds a component to an actor's add. Component. I'm not sure if it's create. This is where it always create. Oh, there, see, this is. I tried putting add component, but there it is. Add component by class. It comes up if I type create, but not if I type add component. Yeah, add component by class. You set the class to. We're using BP underscore electrical connector base. Yeah, and that's what gives us this. Yeah, might as well get rid of that now. So target is self. It didn't actually explicitly say that it was self, so I plugged self in just to make sure. Normally it says target self, but it didn't. It just said target. So I've explicitly put self. So you just right click and just put self, get a reference to self, and plug that into target. Class, like we said, is the electrical connector base, BP electrical connector base, or whatever you've called yours. We're not setting any of these information. The only thing we do need to do is set the object that it's connected to. So we need to link this with this. This is going to be the physical port. This is going to be the virtual power port, yeah? Because it's obviously a different. We can't put blueprints within blueprints, although there is a way, but let's not get into that right now. So to do this, we're linking that to that. So all we're doing is cycling through all these, and we're adding a new one of these for each one of them, and we're linking them. The connection object is each one of these spheres, yeah, and then we add it to our array there. Okay. It's just a bit of tidiness. I don't think we'll end up using it as an array, so we probably don't even need to, because I'd have to explicitly cast to it, and I don't want to keep doing that. So I'm going to leave it as is. So that's basically what we did, or I did. So new function called create ports from our array of BP electrical connectors. We clear it, get all the sphere collisions with ECP underscore O as a tag, because we know what they are, we know they're our ports. We cycle through them, we create a new connector base to match and link them. So this now knows what that is. A pity we can't do it the other way around, but it's not a problem. And we add them to this array, and that's it. Simple as that. But there was a lot of things there missing, because I've got things like a HUD and stuff like that kind of thing working. So I'll go through those in the next episode, so that you can build that up to work the same. But as you can see, we've now got a tool. In the next episode, I'll also now tell you how to hook that up to the standard first-person character. Thing is, though, I'm starting to add a lot of things to the first-person character, so it might be wise for me to make a whole new character that eventually will become the character in the game, so that it doesn't have all just the first-person character stuff in it. We can make it our own. But in the next episode, I will show you how to do the HUD and how to do the first-person character, and how, hopefully, to switch the tool on and off. I hope you understood most of that. I'm sorry if it was a little bit overcomplicated, but there's a lot of work I had to go into, because I was getting fed up with all the errors and things that were popping up, because we was trying to do things in the background. So we've kind of took a step back, but also took a giant leap forward. It's the only thing we haven't got, though. We haven't got working wires yet, and that's because we now need to work those into this new tool that we're using. And I'll show you how I'm actually going to be doing that in one of the other episodes. So we'll get through to the character next, and we'll go from there. Anyway, thanks for watching, and I hope to see you soon. And yeah, next time. Ta-ra for now. Bye bye.